Okay, I'm going to try to run these for you step by step, each of these examples, just so you have an idea of some things that you'll be doing for 8-1. So the first example I want to show you is how to, kind of a reminder of how to take a data table like this and turn it into a scatter plot, and then how to get a regression line for a scatter plot. Most of you might remember how to do this, but some of you didn't even have this course last semester, and this will be a good way to learn it. And for others of you, it'll be a good way to remember it. So you can see there's a data table that I have here, and I'm just going to take all these values and put them into Desmos as a table. So I'm going to show you how to do that first. Pretty much already set everything up, but basically what you would do, I'm going to come down here in example 1 and 2. What you would do is, if you go to this plus sign up here, notice that one of the selections that you can choose is table. If you hit table, then it'll give you something that looks similar to this table that I have here, except that it doesn't have any of the numbers filled in, so you need to fill the numbers in yourself. Once you've filled in the table, what you can do is you can also make a regression line. The regression line is this thing right here, y1 and mx1 plus b. You notice that looks like the formula for a line, y equals mx plus b. What we do is we use y1 because that's what's in the table up here, that's my y variable, and we use x1 for the same reason. And so if we set y1, and instead of saying equals to, we're going to say it's similar to, so that it's approximating where this line should be, and Desmos kind of does the work for you. So you use a little tilde sign there, and then mx1 plus b, and then what it should show you are a few different things. It gives you an r squared and an r value. Those are telling you basically how closely related these points are to a line of best fit. 0.961 is a pretty good r value. Tells you that they're relatively linear. And then at the bottom, notice it gives you a value for m and a value for b. Those are your slope and your y-intercept for this line, this approximation line. So if I go back to one of the questions and the examples in your book, I'm just getting these from your book section 8.1. You'll see that it says something about, based on example 2, what's a good estimate for the amount of monthly rent charged for an 880 square foot apartment. Well, what we're going to do is we're going to use that line equation that we made, and we're going to use 880 square feet as our input, our x value. So if I go back over here, what I did is I basically took the y equals mx plus b sort of format and changed it into r equals ms plus b. The reason I used r and s for this example, and I could actually make a note of this for myself. In the note, I could say r is rent cost, and then I can make another note that reminds me that S is, try that again, S is square feet. Okay, so now I can remember that S is representing my square feet, R is representing my cost, and so if I essentially do an S value, you can see down here I have an S value of 880. If I put 880 in for S and I use the M and the B up here, are going to be the exact same M and B as I have just up above there, then I can get an approximate cost for this apartment. So this apartment would approximately cost $1,200.51 if I were going to the nearest cent. If it was the nearest dollar, I'd just say $1,200. There's that one.